Hello everyone. In this video, we are going to see how we can consume an OData service using SAP's process orchestration OData adapter. When there was no out-of-the-box standard adapter available which could establish connectivity with the OData service, we often use REST or an HTTP adapter, and it was one of the integral part of our design flow, as it could connect to an OData service over HTTP. Now, using a REST adapter for OData connectivity had its own limitation. But with the introduction of SAP standard OData adapter as part of the connectivity add-on, this has replaced our design approach. What is OData? OData actually stands for Open Data Protocol. It's an OSI standard that defines standard and best practices for defining RESTful APIs. It is based on the standard technology and support both query and updating data. It is one of the most widely used protocol and it's easy to implement as it supports both JSON as well as XML format. For our demonstration, in order to consume an OData service, first we have to explore a OData service. For this purpose, we are going to use Northwind's OData service. In order to see different collections and structure of those services, simply open a browser and search for Northwind OData. The first link over here shows the list of collections that are part of this Northwind OData services. Here we can see we have categories, customer demographics, customers, employees, and so on. The same service can also be explored via a REST tool such as Postman. Postman Explorer window, we can simply click on New Collection and create a demo collection for us. Then we can add a request by simply click on Add New Request and give it a meaningful name such as Northwind's OData and save it. For this purpose, since we are not going to invoke anything additionally or to send a payload as a body, we are going to use it as a get method. Simply copy this URL and type it here. As these services are publicly available, there is no authorization that needs to be provided or any user ID or password. Simply click on send. We should see the exact same result. As you can see, the status is 200 OK. That means it's connected successfully. And in the body, we can see all the collections are being mentioned here. Similarly, we can also see how this individual collection will show a message payload. For that purpose, we have chosen customers and simply type it as this. Now click on send. This will call the specific customers collection from the OData service. Down below, here we can see this has actually shown us a valid customer data. Like an example of this is the customer ID, the company name is Alpha, it's Futtercase, contact name Maria Anders, and similarly. And as we can see, this has given us a list of customers from the service. Here in this service, we can also apply various filters. For example, if you would like to select only some selective customer IDs like ALFKI, we can put filters to the service like this, where $ filter equal to our field name, which is customer ID, equal to operator, and then the value. For this case, it will be ALFKI. So I will simply type ALFKI, then hit send. Now in the output, we can see The service is actually responded only with one selected customer ID. Similarly, we can select for more than one ID by simply giving an OR operator and repeating this same thing as a parameter again and selecting for another value like Anton. Now we can see this service has responded with two different distinct customer IDs. One is ALFKI and the second one being Anton. So this way, by means of a REST client, we can also consume a OData service. For this demonstration purpose, using SAP Process Orchestration OData adapter, we first have to generate the schema definition. For that purpose, we can use Eclipse OData Service Modeler that will help us generate the access definition or XSD schema. That schema definition can then further be used for generating message type and message mapping that will be used as part of our integration flow. In order to do that, we are going to use Integration Designer perspective in SAP's NetWeaver Developer Studio. To begin with, first we have to select the Integration Designer perspective by clicking on Window, Perspective, Open Perspective, Others, and select Integration Designer. Hit OK. Once done, we first have to create our integration project. New integration project. Give it some meaningful name such as POC underscore OData consumer. Click next. Here you can select the pattern which is point to point. Click on finish. This would actually create a project in our repository. Now, since this is just for the demonstration purpose and for generating the schema definition, we are not actually going to build the complete flow, but just the receiver communication channel. For that purpose, right click and configure a channel. You can define a name. I'm just going to use this as CC underscore OData. Then under adapter type, hit browse. And select OData as an adapter. Go to adapter specific and under adapter specific, simply type the not with service. Since this service is publicly available over internet, the proxy type should be internet. Authentication, I have selected none, which is by default, but based on the OData service and the type of authentication being used, whether it's certificate based or user credentials, simply select the one. We have selected none. Now click on processing tab. Under processing tab, you can define different operations. Since we are only going to consume this service, we'll keep it as get. Under resource part, we have to fill the resource, which is customers. To fetch that automatically from the service, simply click on model. In this model, you can define the address. So address remains same, which is this. We don't have a username or password. Simply click next. If everything goes fine, you will be presented with this pop-up where in the next screen you will have list of collections. Since we are going to do it with the customers, we will simply select customer, hit next, and then in there we can also select the list of fields which we have to pass. Since we are going to use all the fields, we will simply select these all. And as you can see, this will be the part of our query. We can also define conditions such as top 100 records or skip 100 records or 10 records and so on. Click on next. Here we have an option where we can define various filters, where we can see we can skip based on some selected values, or we can define the sort order as well, which is here. But since for this demonstration purpose, we are not going to use this as an actual integration flow, but just for generating the schema definition, simply click on finish. And you will be presented with this pop-up where it says the EDMX file has been created. Simply click on OK. And similarly, you have also generated a schema definition. Customers entity get 0.xsd. Click OK. Now let's go to your Project Explorer and expand it. Under Resources Visitor, we will see the XSD has been generated. Double click on it. And under source, we can actually see the schema definition that has been generated. Now, for our mapping purpose, we would need this XSD. You can simply right click and export. Or you can copy and paste it to a notepad and simply save it as .xsd. Now, let's move on to SAP Process Orchestration Enterprise Service Repository. Now we are in SAP Process Orchestration Enterprise Service Builder, where we have to create our artifacts under our namespace and relative software component version. For this purpose, we have this namespace. Now, in order to use the XSD definition, we first have to import it into our namespace. Simply right click, new, create an external definition. Give it some meaningful name like OData underscore customers and click create. Now select it to XSD and choose the file which you have recently created. Simply select the XSD file and click save and activate. Now, in order to perform a dynamic query, we need to use SAP's own provided XSD, which is available in the connectivity add-on. Select the connectivity add-on version which you are using or which you have installed on your system. Then go to OData, expand it, select the external definition, and query string operation is the one which we are going to use for this mapping purpose. These two XSDs will be used for our request response of an inbound interface. For an outbound interface, we would have to create data types for request as well as response. For the request message, simply create a new data type. I will give it a meaningful name, something like dt underscore OData underscore request. Since we are going to use filter based on the customer ID, I'm only going to use one field which is ID. Right click, insert an element and give it name like customer ID. For the simplicity, we can simply keep it as string and occurrence will be 1. Save it. Once activated, we first have to create a message type. Right click and click on message type. I'm going to use the same name only with the exception of empty versus dt. And select the data type. Select your namespace. Your error should go away. Simply click on Save and activate. Now for outbound interface response message, we can create a new response of our desired structure, or we can use the same schema definition which is being used as part of a response for inbound interface. So next thing would be creating sender and receiver interface. Since this is going to be a synchronous interface, simply change the operation mode from asynchronous to synchronous. Here you can see now we have an option for request and response. Since our request message is going to be a message type, keep it same and select your message type. For our response, as we are going to use the XML schema definition which we have exported out of Eclipse, change this to external definition and select your definition customers. Hit save and activate. Now we have to generate inbound interface. Simply right click new and give the interface name as since this is an inbound interface, we first have to change the category from outbound to inbound. After that, change the operation mode from async to synchronous and select the desired messages. For request and response message, as we are going to use XS3 definition from SAP, the one with name query string operations, I'm going to use a local version copied for my simplicity and under my namespace. Simply change the type to external messages and select the XSD file, query string operations. Click apply. Similarly for response, we are going to use the file which has been generated out of Eclipse operation modeler OData customer. I will use it as a response. Click on save and activate. Now this is time to create the message mapping. Simply right click and go to mapping objects, select message mapping and give it a meaningful name. Since this is going to be our request message mapping, I have given it a name as request. Click on create. Now select the source message and the target message. Since for request message we are going to use the query option, we will simply select the external definition which we have created here under target message. And for the request, we have already created our own message type. We will use it here. Simply map the structure, and since the filtering is to be done based on the customer ID, we will map this customer ID field to the filter. In order to do so, it has to have a specific format, which is customer ID value equals value. Since in the filter, we have to pass the value in a format as customer ID equals to the value, we have defined a small logic where we have made into a format which is desired by the OData service. If we can see, this will be the exact same format which the service is expecting. Rest other messages we don't have to map as we are not going to pass any other field except the filter field. Simply click on Save and activate. Now it's time for us to create our response message mapping. Similarly, follow new message mapping, give it a name as response. This time, as we have not defined any additional message type for our response message, and we are going to use the same schema which has been generated out of Eclipse, we will use same message as source as well as target, and then map each field from source to target. For simplicity, you can select both the root nodes and map. Simply save and activate. Now it's time for us to create our operation mapping. For that purpose, right click, new operation mapping, and give it a meaningful name. Select your sender and receiver interface. Outbound interface, inbound interface, write operations, and then define the message mapping for the request message. Simply select the existing one, click on response, and select the response message mapping. Simply save and activate. With this, we have completed our design objects. Now it's time for us to configure the scenario. For that purpose, simply log in into Integration Builder, or you can use SAP NWDS. For configuration, we have to build our integrated configuration object. Use of SAP NWDS over Integration Builder is totally at user's discretion. For this demonstration video, I am going to use SAP NetWeaver Developer Studio, which is connected to my backend system. In order to create an integrated configuration object, we first have to create an integration flow. It has to be built, deployed, and then the ICO will be generated in the integration builder automatically. To create an integration flow, simply select the integration flow, right click, new integration flow. Give it some good meaningful name. I'm going to use it as if, which is integration flow, OData POC. Now, for pattern, I'm going to use point to point because I'm going to use only one single receiver. Click on point to point, click on next. Here you can define the sender as well as receiver system properties. For my demonstration, I will use it directly within the integration flow. Click on finish. This will create the integration flow in our repository or in our Explorer. Now we have to define a sender, receiver, intermediate mapping, and communication channels. To begin with, simply select sender and define a communication component. You can right click, click on create a new business component, or you can define a existing system. Simply click on existing It will give you the list of all the existing system. Since we are going to use it for with a SOAP center, I'm going to use my component as bc underscore SOAP. Click OK. Similarly for the receiver, right click, assign a system. I'm going to use it with an OData receiver, bc underscore OData. Click OK. Now for the interface part, simply select interface. You can either select it from here by clicking on browse and selecting the desired object, or you can right click and assign an interface. If it is just going to be a pass-through scenario and you're going to use a dummy interface, you can also have a functionality where you can define a dummy interface. Simply click on assign interface. Here you will see the list of objects which are available there. Since our name starts with something as SI, you can either select SI and search it based on a pattern, or you can also find that object here and select OK. This will assign the outbound interface to your center component. Similarly for the receiver component, we can define the interface. It begins with the same name as SI, which stands for service interface, and this time it is going to be a inbound interface. Simply select and click OK. Now in order to have a SOAP channel, we first have to either create a channel or we can assign an existing channel from a template. So for that purpose, simply click here, right click, and you can define a channel from a template to use an existing channel, or you can configure a new channel. Click on configure. Here you can select the adapter type. Since this is going to be SOAP, simply click on adapter type, click on browse. You'll be presented with a list of adapters which are currently installed or available in your system. Simply select SOAP and hit OK. Since it is just going to call a SOAP service and we are not defining anything additionally, there is no need to change anything here. Since it is going to be a synchronous call, we can still keep the quality of service as best effort. If it is going to be async call, you can change the quality of service from best effort to exactly once or exactly once in order. There is no additional module that has to be implemented or used in this scenario. There is no need for doing anything. Simply save all the objects and activate. Similarly, we have to define a OData receiver channel. Simply click on channel, right click and configure a new channel. This time we are going to use a data type as OData. Select it, hit OK. Since this is going to consume an OData service which is exposed externally, we have to define some specific parameters. For that purpose, click on adapter specific. Here you have an option where it says connection details, use an HTTP destination. One option is you can define an HTTP destination in NWA and use it from here, or you can define it manually directly in the communication channel. As we are going to use it directly within the communication channel, simply uncheck this box and define the address. In address, we are going to pass the same address URL which we have used in Postman, which is the Northwind service URL. Since it's a publicly available open OData service which doesn't need any authentication, we simply have to select no authentication. And as our system is not behind a proxy, I'm not going to configure anything under proxy setting. Now click on processing. Under processing, since we are going to use it for query, you can select query by default, or based on the operation which we are going to use as create, update, read or merge, you can define the different options. Under resource path, I'm going to call my customer service or my customers collection. Simply type customers. This is sufficient. Now since we have used a filter, we have to define it here as well as dollar filter equal to filter. This variable here, filter, will define based on the runtime value which will be passed as part of our message mapping, where we have mapped the customer ID value concatenated with equal and then the value to the filter element. For payload format, you can either use atom, which is similar to XML, or a JSON method. Since our service, we are going to use it only for XML, I will keep it as atom. Under advanced tab, no additional setting has to be performed, and there is no additional module that needs to be implemented or used in this communication channel. Simply save and activate your communication channel. Coming back to our integration flow, now we have to assign a mapping object to it. Right click. You can either define various properties such as recipient list if it has to be a multicast message, a interface split, or any additional interface. Since this is just a plain mapping which we have used, I will assign a mapping object to it. Select add mapping, and under add mapping you can define the mapping object of your choice. Assign a mapping. Simply select the operation mapping which we have created in our enterprise service repository. Select it and click OK. With this, our integration flow is ready to be built and deploy. For that purpose, simply select your integration flow, right click and select activate. You will be presented with a question. If you would like to activate your integration flow, click yes. This will activate our integration flow. Now, this integration flow will not be available in our integration builder. For that purpose, we have to right click and select deploy. Right click. Again, we will be presented with a question whether we would like to deploy our integration flow. If underscore OData underscore POC, simply click yes. And under the deployment log here, you can see the deployment has actually started. Once the deployment is finished, we will be presented with a pop-up stating the deployment has finished successfully. If there are any relative errors, you will also get a log of the list of errors which we have received. Since for our case, we have successfully deployed the object, we can see the status as finished. Now we can head back to our integration builder to see how the integrated configuration object or ICO has been generated. Now we are in the integration builder. As you can see, our integration flow has successfully been deployed, and at the same time a related integrated configuration or an ICO has also been generated, which we will also find it under integrated configuration option. Simply double click on it. This will open up the ICO object. You can see the selected sender and the receiver component has already been pre-populated in the ICO along with the communication channels for sender as well as for receiver, and we will have the desired operation mapping under our mapping tab. In order to do end-to-end testing of this scenario, we have to call the SOAP service which we have defined here. For that purpose, we can generate a WSDL or web service definition file from the integrated configuration object, and the same can be consumed using any SOAP client such as SOAP UI. To generate the WSDL file or web service definition, simply click on integrated configuration and click on display WSDL. It will take some time and then the WSDL definition will be presented to you. Simply click on save and choose the desired directory where the file has to be downloaded. Once that is done, the same WSDL file can be consumed using any SOAP client such as SOAP UI. Now, in order to test this integration scenario, we are going to use Boomerang as our SOAP client. Boomerang is very fast and easy client that can be used to access SOAP as well as RESTful services. Boomerang can be accessed either via heading on to their URL, which is app.boomerangapi.com, or it can also be configured in our Chrome browser as an extension. Since I already have Boomerang extension installed in my Chrome browser, I'm going to use it. Simply head on to the extension. You will be presented with a welcome screen. As we are going to use it for accessing our SOAP service via WSDL file, I will simply head on to import services from WSDL. Click on add service. You will be presented with this screen where you have two options. First, you can either call the service directly out of SAP Process Orchestration, or we can select the file. Since we already have downloaded the WSDL file, I'm going to select it by simply click on Browse. Simply go to the directory, select the file, click Open. After that, click Load. Now our service definition has been loaded. Simply click on Add. This will create the service on the left hand side in the project browser. Now it's time to test. In order to do that, first we have to generate a request message. Simply click your service, right click and click on New Request. Since we are using a WSDL file, automatically the request message will be generated. Previously, we have selected a specific customer ID as Anton for testing the OData service by means of filters. I'm going to do the same thing here. Simply pass the value in the customer ID field as Anton. Since this is going to call our process orchestration service, we will need to pass on the authentication. Since we are going to use client credentials, I'm going to use authentication and then type basic. On the screen, simply pass on the username and the password. Now head back to the request message. To test it, simply click on Send. If everything goes fine, you will be presented with HTTP status code of 200. That means everything is successful and we have been successfully able to call the web service. Here on the response message, we can see we have successfully gathered the response for the customer ID Anton. With this, we have successfully demonstrated how we can consume an OData service via SAP's process orchestration OData adapter. Thank you for watching.